It feels like AI is moving at absolute warp speed these days, right?
Hmm.
Every week there's a new model, a new capability, a new headline. It's genuinely hard to keep up with what's really happening beneath all the hype.
Absolutely. Yeah, the pace is just unprecedented. And, understanding the actual state of play, it means sifting through a huge amount of information, lots of different sources.
Which is exactly why we're doing this deep dive.
Yeah.
We've taken a stack of material for you, leaning pretty heavily on the Artificial Intelligence Index Report 2025,
Right.
but also pulling in insights from like a Harvard Gazette article and even a Reddit discussion.
Right.
Our mission, to try and cut through all that noise and pull out the most important nuggets,
Mm-hmm.
the surprising facts, the key insights from all this stuff.
Yep.
We want to help you understand the critical shifts, the breakthroughs, and yeah, the challenges defining AI right now.
Think of it as your shortcut, maybe, to being well informed on the bleeding edge of AI.
Mm-hmm.
We're going to start with the sheer, real technical progress we're seeing, then kind of peel back the layers, look at the costs and complexities underneath.
Like the hidden stuff.
Yeah. After that, we'll explore the real-world economic and societal impacts that are already taking shape. And finally, dig into those absolutely crucial issues of responsible AI and governance.
Okay, let's jump straight in then, the technical side. The sources really paint a picture of AI not just getting better, but like blitzing through benchmarks at an incredible pace.
That's right. I mean, we're seeing huge performance gains on really complex tasks. The ones that test models across different domains.
Yeah. Like what?
Well, for example, on benchmarks like MMMU that measures multimodal understanding and GPQA, which is focused on complex reasoning, models showed gains of nearly 19 and almost 49 percentage points.
Wow, 49 points in just 1 year.
In a single year, yeah. It's remarkable.
And coding. I remember AI used to really struggle with complex coding problems.
Oh, definitely. But SWE Bench, which is specifically for those kinds of tough coding problems, saw model performance jump from, get this, a mere 4.4% in 2023 to a staggering 71.7% in 2024.
Okay, that's almost unbelievable, that kind of leap.
It is. And, tasks where AI previously fell short of human performance, like visual common sense reasoning, VCR,
Right.
AI is now matching or even surpassing humans there. A top model hit 85% on VCR this year, basically reaching the human benchmark. And we also saw a really specific AI for geometry, alpha geometry 2, solve an international mathematical Olympiad problem in just 24 seconds during the actual competition this year.
Okay, so these aren't just tiny tweaks, they're like fundamental capability shifts.
Exactly. Big jumps.
What's fascinating here, though, looking at the data you mentioned, isn't just the individual games, but how the top models are performing relative to each other.
Yeah, this is a key insight, right? From the chatbot arena leaderboard data, the performance gap between the top model and the 10th model, it shrank significantly.
Am I?
Went from about an 11.9% difference down to just 5.4%.
Okay.
And even more striking, the difference between the top two models went from a noticeable 4.9% to like a tiny 0.7%. It really suggests this rapid convergence among the leading frontier models.
So basically, everyone at the cutting edge is getting really, really good really fast.
Yeah.
And they're all kind of clustering at the very top.
Mm-hmm.
And it's not just the huge proprietary systems doing this, is it?
Exactly. The sources indicate that open weight models, the ones where the inner workings are publicly available, they're rapidly catching up to the closed weight ones.
Oh, rapidly.
The performance gap, it narrowed from over 8% down to just 1.7% in only 1 year.
Okay, that's huge for accessibility, right?
Right.
And competition.
Massive implications, yeah.
And speaking of accessibility,
Uh-huh.
we're seeing this incredible performance packed into smaller models, too.
This is perhaps one of the most significant trends for actually deploying AI. Think about it. Just 2 years ago, to get a respectable score on MMLU, that's a common benchmark for general knowledge and reasoning,
Right.
you needed a massive model like Google's PaLM, 540 billion parameters.
Okay, huge. Now, Microsoft's Phi 3 Mini gets basically the same performance threshold with only 3.8 billion parameters.
Wait, 540 billion down to 3.8 billion?
Yeah.
What is that, like a 142-fold reduction?
142-fold reduction in size, yeah.
Hey, could be.
For equivalent performance on that specific test.
Just think about what that means for running AI on, your phone, or for smaller companies, researchers who don't have supercomputers.
Exactly. And beyond just general language stuff, specific AI capabilities are leaping ahead too. High-quality AI video generation, for example.
Oh, yeah, Sora and things like that. Yeah.
Right. OpenAI Sora, Meta's Movie Gen, Google DeepMind's VO2. They're producing much, much higher quality videos compared to just 2023. Some can now do 1080p video up to 20 seconds long for pro users. Big improvement.
And AI is increasingly moving into really specialized fields, too.
Yes, we're seeing foundation models starting to arrive in medicine, really tailored to specific tasks.
General multimodal medical models like MedGemini, which can handle different types of medical data, but also specialized ones for, say, echocardiology with EchoC ophthalmology with Vision FM, radiology with ChecksAgent.
They're designed to actually help doctors analyze complex info.
Precisely. Assisting practitioners.
Protein science is another area mentioned.
Yeah, models like ProGen, advanced transformer models like ProT5, they're significantly pushing forward protein structure prediction and engineering.
And that's helped by more data being available.
Absolutely. Huge growth in public protein databases like AlphaFold. It's grown like 585% since 2021. That provides the crucial data needed to train these specialized models.
Crucially, though, none of this technical progress happens in a vacuum, right? It relies on the hardware.
Oh, completely. The underlying hardware advancements are critical. The performance of machine learning hardware, specifically for the kind of math AI needs, is growing incredibly fast, about 43% annually.
So it's doubling roughly every 2 years.
Doubling every 1.9 years, yeah.
And faster and more efficient, I saw.
Right. Price performance is improving costs, dropping about 30% per year. So you get more compute power for your money. And energy efficiency is up 40% annually.
So those faster, more efficient GPUs are really the engine driving a lot of this.
They are absolutely the engine, no question.
The sources also highlighted some newer concepts, things beyond just making bigger language models.
Yeah, things like exploring multimodal models and joint embedding, basically teaching AI systems to understand the connections between different types of data, like text, images, audio, all together.
Okay.
Also areas like NeurIFs, neural radiance fields for really advanced 3D scene reconstruction.
Oh, yeah.
And research into more reliable algorithms, moving beyond just statistical pattern matching towards things like causal modeling, understanding cause and effect.
Right, not just correlation.
Exactly.
Right.
And augmenting AI memory for more robust, trustworthy systems. That's especially critical in sensitive areas like medicine or, education.
Okay, moving towards systems that don't just spot patterns, but actually understand why things happen, or can reliably remember stuff. Makes sense.
However, this picture of, dazzling technical progress, it doesn't tell the whole story.
Oh, okay.
The sources reveal some pretty significant challenges lurking just beneath the surface.
Okay, here's where it gets really interesting, maybe. That incredible performance comes at a cost. And you mean a literal staggering cost.
The training costs for these frontier models have just exploded. Look at this comparison from the sources. It's pretty stark. The original Transformer model back in 2017 cost about $670 to train, adjusted for inflation.
Okay, pocket change, relatively speaking.
Right. Then Roberta Large in 2019 cost around $160,000.
Okay, scaling up.
Fast forward to 2023. GPT-4 is estimated to have cost around $79 million to train.
Wow. $79 million for one model's training run.
Yeah.
That just highlights who can actually afford to play at the very top tier now, doesn't it?
Exactly. It fundamentally changes the landscape of who can push the frontier. And another major challenge highlighted is this idea of the shrinking data commons.
Right. The data AI trains on.
AI models rely so heavily on training data, right? And historically, a lot of it came from the public web, but websites are increasingly restricting access.
Like a really significant increase in restrictions.
Yes. The proportion of web data tokens, basically chunks of text, from actively maintained domains in data sets like C4, that's a very common one, the proportion that have usage restrictions, it jumped from maybe 5-7% in 2023 to somewhere between 20 and 33% in 2024 alone.
Whoa.
Yeah, many websites are specifically updating their terms of service, their robots.txt files, to prohibit AI training use.
And this is obviously tied to the legal battles we're seeing, isn't it? Like the New York Times suing OpenAI over using their articles.
Absolutely connected. Fair use is being heavily contested, and this shrinking data pool, it has serious potential implications.
Like what?
Well, concerns about data diversity. Are models becoming biased because they're trained on a smaller, maybe less representative slice of the web now? And it directly impacts scalability. If you want to train even bigger, better models in the future, where is all that necessary data going to come from?
That's a huge question. Okay, and what about the benchmarks themselves, the ones AI is mastering so quickly? Are there issues with how we're evaluating these models?
Absolutely, yes. While some existing benchmarks are getting, saturated models are hitting the ceiling, requiring new, tougher ones,
Right.
analysis frameworks like Better Bench, they're pointing out systemic deficiencies in many of the prominent benchmarks we use right now.
Systemic deficiencies, like what kind of problems are we talking about?
Things like a lack of statistical significance reporting.
Hmm.
Are the improvements actually meaningful? Missing scripts to replicate the results, which is crucial for science. Inadequate documentation. Just basic quality control issues.
So it's hard to be sure the results are real or repeatable.
Yeah, and some widely used benchmarks like MMLU that we mentioned earlier didn't fully adhere to these quality standards when they were evaluated.
Plus, there's that issue of model developers sometimes reporting scores using non-standard techniques, right? Or models doing worse when someone else tests them independently.
Exactly. Like Google's Gemini Ultra reportedly using a specific type of prompting on MMLU that wasn't standard at the time, it makes direct apples-to-apples comparison really difficult.
And it can erode trust in the progress being reported?
For sure. It really underscores the need for more standardized, more rigorous benchmarking, especially since these scores influence so much policy decisions, funding, everything.
And even with techniques like chain of thought, complex reasoning is still a big hurdle.
Still a significant challenge, yes, especially for generating provably correct solutions. Logical reasoning, step-by-step deduction, AI systems still struggle there.
And in those specialized fields like the medical imaging we talked about, specific data limitations are slowing things down too.
Correct. Finding large, publicly available 3D medical datasets is much harder compared to 2D data or just general image datasets like ImageNet.
Hmm.
And standardization is a major hurdle too because you have different scanning equipment, different medical practices. It's tough to pool data effectively. Even text datasets for medical language models are just orders of magnitude smaller than what's used for general LLMs.
So what about synthetic data then? Generating artificial data to train models. Is that filling the gap from the shrinking data commons?
Well, the sources indicate there are definitely advances. People are generating higher fidelity synthetic data, but generally it's still distinguishable from real data.
Oh, okay.
And crucially, there isn't yet a scalable method that's been shown to achieve the same level of performance when training large language models purely on synthetic data compared to using real data.
So it's not quite the magic bullet yet.
Not for the biggest LLMs, it seems. Although it's worth noting, some specific use cases look promising. One study training a classifier on Walmart data, for instance, found synthetic data actually did outperform real data in that particular scenario.
Interesting. So specific applications might work, but the dream of infinite, cheap, perfect synthetic data for training the biggest, most capable models that isn't quite here yet.
Not at the scale and quality needed for frontier LLMs, based on what these sources indicate, yeah.
Okay, let's pivot a bit from the technical hurdles to the real-world impact. With all this capability developing so fast, how does AI actually affecting the economy and society right now? What are the sources saying?
Well, we're seeing pretty concrete evidence now of AI boosting productivity in certain areas. One study cited showed customer support agents using AI assistants achieved a 14.2% increase in the number of issues they resolved per hour.
Okay, a measurable boost. And surprisingly, perhaps, it seems to be particularly beneficial for workers with maybe lower skill levels in their specific role.
Yes, that's a fascinating finding across a couple of studies. Greater productivity gains for workers in less skilled roles, like that 34% gain in customer support we just mentioned, or even a 42.96% gain in certain consulting roles, compared to high-skilled workers doing the same jobs.
Why is that?
It suggests AI can act as a kind of tool to bridge skill gaps. It provides assistance on tasks that require, say, critical thinking or writing, effectively leveling the playing field somewhat.
Interesting. And how are organizations actually using AI? Is it mostly replacing people or helping them do their jobs better?
The analysis points more towards AI being used to enhance human capabilities, actually. About 57% of the AI interactions observed showed what they called augmentative patterns, AI assisting the human, versus 43% showing automation patterns. And it's interesting which skills AI is interacting with. Cognitive skills like critical thinking, writing high presence, meaning AI is helping there. Physical skills, managerial skills, minimal presence in current AI use cases within organizations.
Right. And these productivity gains, they aren't automatic, are they? It really depends on how organizations implement AI.
Exactly. That's a crucial point. Productivity gains are strongly correlated with comprehensive AI integration and systematic implementation.
How strong is the correlation?
Well, one study showed a 72% probability of achieving significant gains when AI was highly integrated across the organization. Compare that to just a 3.4% probability with minimal integration.
Wow. So it's not enough to just buy the tech. You have to really weave it into how the organization works.
Precisely. Effective integration is key.
Another clear indicator of AI's growing economic footprint is patenting activity, right?
Oh, yeah, significant growth there. AI patents globally just ballooned from under 4,000 in 2010 to over 122,000 in 2023.
Over 122,000. And that's a big jump recently.
Nearly a 30% rise in just the last year alone. China leads in the total number of AI patents filed,
Mhm.
while smaller countries like South Korea and Luxembourg actually lead when you look at patents per capita.
Interesting. And where is the AI talent concentrated globally? Any surprises there?
Well, Israel, Singapore, and Luxembourg have the highest concentration of AI talent relative to their overall workforce size.
Okay.
But what's really striking is the rapid increase in countries like India, Costa Rica, and Portugal. They've seen incredibly fast growth in their AI talent pools since 2016, more than doubling their concentration.
So talent is becoming more globally distributed, perhaps?
It seems to be moving in that direction, yeah.
What about education? Are we preparing students around the world for this AI future?
We're seeing significant progress, definitely, in computer science education globally. About two-thirds of countries now offer or plan K-12 computer science education. That's double the number from just 2019.
Double. Wow.
Yeah, with really notable progress in Africa and Latin America, which is great to see. And in the U.S., there's been a 22% increase in computing bachelor's degrees over the last decade.
Okay, so progress.
Uh,
But the sources also highlight some major gaps that still remain.
yes, absolutely. Big gaps. I mean, basic infrastructure like reliable electricity is still a huge barrier in many African countries for any kind of digital learning.
Right, foundational stuff.
And even in the U.S., there's a disconnect. Most K-12 computer science teachers believe AI should be part of foundational education, but less than half feel adequately equipped to actually teach it.
Hmm. The will is there, but not the training or resources yet.
Exactly. And there are still persistent equity gaps in access based on geography, race, ethnicity, and for girls. So while the intention to prepare students is growing, the implementation is pretty uneven.
And finally, just thinking about the sheer scale of AI,
Yeah.
the sources highlighted this increasing connection to energy needs.
Yes, that was quite striking. Companies like Microsoft and Google making major deals for nuclear energy, specifically to power their massive energy-hungry AI data centers.
Wow, AI needing nuclear power.
Yeah,
That really puts the scale and the resource requirements into perspective, doesn't it?
it absolutely does. It's a very tangible sign of the infrastructure involved.
Okay, let's move on to the crucial and maybe the most challenging aspect here. Responsible AI and governance. This is where the sources seem to show some significant friction points.
This is indeed where the rubber meets the road, as they say. The sources confirm that AI-related incidents, things ranging from bias issues to privacy violations, safety concerns, they are rising sharply.
Sharply. And there seems to be this kind of disconnect between companies recognizing the risks, maybe talking about principles, and then actually taking meaningful, consistent action.
That gap between recognition and widespread, impactful action on responsible AI principles, yeah, it's definitely apparent in the data.
But governments are moving faster now.
In stark contrast, yes.
Yeah.
Governments and global organizations showed a really significant increase in urgency around AI governance just in 2024. Global cooperation intensified. You have organizations like the OECD, the EU, the UN, the African Union, all releasing frameworks focusing on transparency, trustworthiness, other RAI principles.
And the EU AI Act is a big piece of that puzzle, right? Often described as pretty comprehensive, maybe even restrictive.
It's definitely a landmark piece of legislation, yeah.
Yeah.
Coming into effect mostly in 2026. And the U.S. has its executive order now requiring notification of investments in sensitive tech, including AI, with entities in certain countries of concern. So governments are moving to put guardrails in place.
It feels like a global trend towards more formal governance then. But you mentioned a challenge in actually evaluating responsible AI compared to just measuring technical capability.
Yeah, what do I mean by that? Well, While the major developers use standardized benchmarks for general capabilities like the math, coding, language stuff we talked about earlier.
Right, the scores they boast about.
Exactly.
Yeah.
There's a distinct lack of standardized benchmarks for evaluating AI safety, fairness, bias, those kinds of responsibility aspects.
Ah. So it's harder to compare models on safety than on, say, math ability.
Much harder. And that makes it difficult to really assess these crucial aspects consistently before models get deployed out into the real world.
The Harvard Gazette article you pulled from also highlighted some core ethical concerns that play right into this.
Yes, absolutely. Issues like privacy and surveillance, the potential for bias and discrimination, and that complex question of keeping the right role for human judgment. Especially as AI takes on bigger decision-making roles in really sensitive areas.
Like lending.
Yeah, the article specifically mentioned the potential for AI in lending decisions to unintentionally replicate historical biases against underserved borrowers. If you're not careful, you just give existing prejudices a kind of algorithmic objectivity. Needs very careful management.
And the sources also gave specific examples of these kinds of responsible AI issues actually happening.
They did. There was that incident with the Character.ai chatbot exploiting the identity of a deceased individual.
Yeah.
That really highlights gaps in platform oversight, user policies, and just the huge ethical dilemmas around digitally recreating people. The report also notes that incidents reported by organizations often include things like adversarial attacks, privacy violations, and importantly, unintended decision-making and model bias creeping in.
And then, of course, there's AI's role in misinformation. That feels like a huge and growing concern, especially with elections.
Oh, critical area. The sources really delve into this. They explain that concept of the liar's dividend.
Right, explain that again.
The idea is by creating convincingly fake content deepfakes, whatever you erode overall trust in any evidence. So bad actors can then deny genuine facts just by claiming they're fake too. It muddies the water completely.
And the potential for blackmail using fabricated deepfakes or AI just amplifying hate speech online.
Exactly. And we saw specific election examples highlighted too. Claims circulating that a photo of Kamala Harris at a rally was AI generated.
Okay.
An AI-generated picture of Taylor Swift falsely endorsing Donald Trump. Even an AI-generated image of potholes used to try and influence voters in South Africa.
So these aren't theoretical risks. These are real-world instances of AI being deployed to spread misinformation and undermine trust right now.
Happening now. Yeah.
Safety research is trying to fight back against this, though. You mentioned LAT.
Yes. Targeted Latent Adversarial Training, LAT. It's one method researchers are working on, aiming to make models more robust against these kinds of adversarial attacks. It can even help remove backdoor vulnerabilities or prevent models from relearning harmful or copyrighted content more efficiently. So technical fixes are being explored.
And what about transparency? Are companies getting any better at telling us what's going on inside these models?
There are some signs of improvement. According to indices like the Foundation Model Transparency Index, the average scores have increased significantly in recent months,
Why?
mostly due to more disclosures from developers. They're sharing a bit more.
But. There's a but, isn't there?
But there's still significant opacity, yes, particularly around crucial details like the specific data used for training and its copyright status. Lots of unknowns remain.
Got it. And finally, the sources touched on that ongoing debate about how AI should even be regulated.
Right. Should we have one big centralized AI watchdog agency? Or should existing industry-specific bodies, like, say, the National Highway Traffic Safety Administration, handling autonomous vehicle AI, manage AI within their own domains?
The challenge there being that those existing bodies might not have the deep technical AI expertise needed, right?
Exactly. They might lack the specific knowledge. It's a really complex governance problem with no easy answers, and the pace of the tech is just clearly outstripping the traditional speed of regulation.
Okay, so if we try and pull together the key threads from this whole deep dive,
Yeah.
what's the big picture?
Well, AI is advancing technically at an absolutely astonishing pace, no doubt about that.
Yeah, unlocking new capabilities, coding, medicine, video boosting productivity in some areas, shifting the economic and talent landscape globally.
Correct. But this rapid progress comes with really significant costs, creating high barriers to entry, especially for frontier research.
Right, the $79 million training cost.
Exactly. And it faces fundamental challenges around getting enough diverse data and persistent issues with the reliability and standardization of how we even evaluate these things, especially for complex reasoning.
And alongside those technical hurdles, we're seeing mounting ethical concerns playing out in the real world. Bias, misinformation.
Hmm. And a growing urgency from governments and global bodies to put governance frameworks in place. Although concrete industry action on responsible AI risks still seems to be lagging a bit behind that regulatory push in some areas.
So the picture that emerges is one of dynamic but uneven progress. Breathtaking breakthroughs right next to significant costs, resource challenges, and these critical, unresolved questions around safety, fairness, accountability.
But that sums it up pretty well, I think. Uneven progress is a good way to put it.
And understanding these intertwined trends, well, it feels absolutely essential for navigating the landscape ahead, doesn't it? It touches the jobs you might do, the information you consume, the healthcare you might receive, the policies being debated.
Absolutely.
Yeah.
It highlights the need for all of us to have informed awareness, critical thinking as these systems get more and more integrated into our daily lives.
Which leaves us with a final, maybe provocative thought for you, the listener, to consider. Given this incredible, fast-paced technical progress on one side, and the slower, more uneven evolution of responsible AI practices and governance on the other, what's the most critical aspect you feel you need to focus on to help ensure AI development actually benefits society safely and equitably? Is it deeply understanding the technology itself? Is it pushing for better, faster regulation? Or maybe demanding more transparency and accountability directly from the developers building these powerful systems? What really stands out to you from everything we've dug into today?